Please note that the following broadcast is an artificial intelligence-generated analysis.
This program is designed to deliver a formal, carefully measured, and highly professional review of our selected subject material.
Welcome to our comprehensive analysis of the book, The Complete Developer. Master the full stack with TypeScript, React, Next.js, MongoDB, and Docker by Martin Krause.
Our mission today is to thoroughly examine the architecture of modern web applications and to understand the specific technologies required to build them.
Okay, let's unpack this. The core concept of the book revolves around the definition and execution of full-stack web development. For you, the listener who already understands the basic building blocks of software, we're going to explore how this specific stack unifies the entire engineering process.
Full-stack web development traditionally required a developer to constantly switch contexts between completely different programming languages.
Which I imagine was incredibly frustrating.
It was. You had your front-end user interface rendered in the browser, your middleware handling the server-side APIs, and your back-end managing database operations.
All entirely separate ecosystems.
Right. What Krause emphasizes in this book is the profound shift that occurred when JavaScript became capable of handling all three of these layers.
And this evolution, it was really propelled by the release of the Node.js runtime back in 2009, right?
Exactly. And later, the creation of the React library in 2013, these two technologies allowed developers to use a single language reliably on both the client side and the server side.
Which drastically reduced the cognitive load required to build complex applications.
It changed everything.
So, we begin our detailed technical review by looking at the foundation of that server-side revolution in Chapter 1, which focuses entirely on Node.js.
Node.js is an open-source runtime environment.
Crucially, it executes JavaScript code completely outside of a web browser.
Yes, because before Node.js, JavaScript was trapped.
Trapped inside the browser.
Yeah. Useful only for making web pages interactive. By bringing JavaScript to the server, Node.js allows the language to interact with the file system, manage memory, and perform background tasks on a standalone machine.
So developers primarily use Node.js to create robust web servers.
They do. However, writing a web server from scratch using purely native Node.js it can be really tedious.
I can imagine.
So to accomplish this efficiently, developers frequently utilize a framework called Express.js.
Express.js. And that simplifies the complex process of routing network requests, right?
Yeah, and managing HTTP server responses. Alongside Node.js, developers rely heavily on a tool called NPM.
Node Package Manager.
Right. This tool manages application dependencies, which are the external libraries of code that a project requires to function.
And the Node ecosystem relies specifically on two files to solve that notorious problem of, code working on one machine but breaking on another.
Ah, the classic "it works on my machine" problem.
Exactly. So first you have the package.json file.
Which tracks which general packages the project needs.
Right. Then the package-lock.json file securely locks down the exact versions of those packages,
ensuring that the application runs consistently across different environments, whether it is on your local laptop or a production server.
Here's where it gets really interesting. Chapter 2 transitions from basic JavaScript into modern JavaScript, often referred to as ES Next.
This transition introduces powerful features, starting with the critical concept of asynchronous programming.
Because JavaScript is single-threaded.
Right, meaning it can only run one task at a time. So managing long operations is incredibly important.
Because if a developer instructs the program to read a massive file from a hard drive, or call a slow remote API,
that operation will block the entire application.
The user interface would just freeze entirely until the task finishes.
Which is terrible for the user. So developers must use asynchronous programming to prevent this blocking behavior.
By making a task asynchronous, the program starts the long-running operation in the background.
And immediately continues executing other code while it waits for a response.
And the technique for handling these asynchronous tasks has evolved significantly. Initially, developers used traditional callback functions,
which often led to what developers jokingly call callback hell,
where nested code begins to look like a sideways pyramid
and becomes basically impossible to read. The language then introduced promises,
which provided a much cleaner chain structure for handling eventual results.
And finally, modern JavaScript introduced the async and await syntax. This allows developers to write asynchronous code that reads sequentially from top to bottom,
making the logic much easier to understand and maintain. The book also covers several other crucial modern syntax features that make writing this code much cleaner.
Like ES-Next module.
Right, which allow developers to organize their code into maintainable, isolated packages, explicitly exporting and importing only what is necessary between files.
And arrow functions, which provide a shorter syntax for writing function.
And more importantly, they handle the internal lexical context of the code more predictably.
Then there's the spread operator. That allows developers to quickly copy or merge arrays and objects without mutating the original data.
Finally, tagged template literals allow developers to create custom text processing functions. These are highly useful for creating domain-specific languages.
Or DSLs, which are specialized mini-languages designed for a very specific task within the application ecosystem.
What's fascinating here is the introduction of TypeScript in Chapter 3.
Yes. TypeScript is a strict syntactic superset of JavaScript.
Meaning any valid JavaScript code you write is automatically valid TypeScript code.
However, TypeScript adds the feature of static typing to JavaScript, which is traditionally a dynamically typed language.
In standard JavaScript, a variable can hold text, and then 10 lines later it can be reassigned to hold a number.
Which is great for flexibility, but that flexibility often causes unexpected crashes in production. Static typing forces the developer to define exactly what kind of data a variable will hold from the very beginning of the process.
This mechanism helps developers catch errors early in the writing process, directly inside their code editor, long before the code is actually executed or deployed.
Instead of listing out every single primitive type robotically, the book organizes these built-in types into logical categories.
You have primitives like strings and numbers, but you also have complex structures. The union type allows a variable to explicitly hold one of multiple specified types.
The tuple type represents an array with a fixed number of elements of known types.
The void type simply indicates that a function does not return any value at all.
And the any type acts as an escape hatch, allowing any data type to bypass the system, though the author notes its use is generally discouraged.
Beyond these built-in options, developers can construct highly specific rules for their business logic by defining custom types and interfaces.
TypeScript is designed to be highly efficient for the developer. It utilizes type inference,
which is a process where the system automatically guesses the type of a variable based on its initial value.
This saves the developer from writing redundant type declarations everywhere. However, because web browsers and Node.js environments do not natively understand TypeScript, the code cannot be run directly.
It must be transpiled back into standard, backward-compatible JavaScript.
Right. And this conversion is handled by the TypeScript compiler, widely known as TSC.
The entire compilation process, including how strictly the compiler should enforce rules, is configured according to a local file named tsconfig.json.
So we have an incredibly efficient, non-blocking server running Node.js and TypeScript in the background.
But as a user, you never see that. You only see the visual interface.
Moving to the front end, Chapter 4 examines React.
React is a declarative library used to build reactive user interfaces, instead of manually updating the screen pixel by pixel using imperative commands.
Developers declare exactly what the interface should look like based on the current state of the data.
And React then handles all the complex DOM updates automatically.
This library is exceptionally powerful, currently powering over 40% of the most visited websites on the internet.
React operates on two core mechanics to achieve this performance. The first is JSX, which stands for JavaScript Syntax Extension.
JSX allows developers to write HTML-like code directly inside their JavaScript logic,
keeping the visual structure and the programming logic closely unified in a single component file.
The second mechanic is the virtual DOM. Updating the actual web browser display is a computationally expensive and slow operation.
So to solve this, React creates a lightweight virtual copy of the display in memory.
When your application data changes, React updates this virtual copy first.
It then calculates the absolute most efficient way to change the real display by comparing the new virtual copy to the old one.
And finally applies only those specific necessary changes.
React provides reusable behaviors using special functions called built-in hooks.
The useState hook allows a component to manage its own internal data memory, like tracking whether a drop-down menu is currently open or closed.
The useEffect hook manages side effects,
such as fetching data from a server or setting up a chat subscription, ensuring these external actions happen at the correct time in the component's lifecycle.
The useContext hook is particularly useful because it allows developers to share global data,
like a user's login status or a dark mode visual theme,
across the entire application without passing that data manually through every single layer of the interface.
Chapter 5 introduces Next.js, which is the leading framework built directly on top of React.
While React is a library focused solely on building the user interface, Next.js provides a complete architectural framework for creating structured web pages and custom API routes.
Next.js achieves this using file-based writing.
Meaning the physical folder structure of the code project automatically becomes the URL structure of the website.
Completely removing the need for complex manual routing configurations that often plague large applications.
Next.js provides multiple rendering methods to deliver these web pages to the user, and choosing the right one is critical for performance.
Server-side rendering, or SSR, generates the HTML for a page on the server every single time a user requests it.
This ensures the data is always up to date, which is perfect for dynamic dashboards, but it requires more server processing power.
Static site generation, or SSG, takes a different approach. It generates the HTML for all pages during the initial build process before the site is even deployed.
These pre-built pages load incredibly fast, making them ideal for blogs, but they do not update until the entire site is rebuilt.
Incremental static regeneration, or ISR, combines the best of both methods.
Serving static pages for immediate speed, but it automatically updates specific pages in the background after a set time limit expires.
Finally, client-side rendering, or CSR, sends a bare-bones HTML page to the browser and relies entirely on JavaScript to fetch data and build the interface directly on the user's device.
Next.js also includes built-in tools for application optimization.
The next head component allows developers to dynamically modify the metadata of a page,
which is critical for search engine optimization and sharing links on social media.
And the next image component automatically resizes, optimizes, and serves images in modern web formats,
drastically improving the loading speed of the application without requiring the developer to manually compress every single image file.
So what does this all mean? We have a front end displaying data and a back end managing databases.
Chapter 6 focuses on the application programming interfaces, or APIs, that bridge these two layers.
The first API architecture discussed is REST, which stands for Representational State Transfer.
REST is a traditional architectural pattern that relies on standard URLs and standard HTTP methods to communicate with stateless servers.
A stateless server treats every single request as a completely new transaction, retaining no memory of previous interactions.
The communication uses HTTP methods to perform fundamental operations, often referred to as CR-root operations.
Create, read, update, and delete. A client sends a standard HTTP request to a specific URL, and the server returns the requested data, typically formatted as a JSON object.
But REST is not perfect, which is why the book contrasts REST with the GraphQL solution.
GraphQL was designed to solve two incredibly common problems found in REST architectures.
The first problem is overfetching. Imagine a client requests a simple list of usernames for a sidebar widget.
But the REST API returns the entire user profile, including their address and payment history, wasting massive amounts of bandwidth.
The second problem is underfetching.
This happens when a client must make multiple separate requests to different URLs just to gather all the necessary data to build a single page view.
GraphQL solves both of these problems by providing a single endpoint for the entire application.
The client uses a strictly typed schema to request exactly the data it needs, nothing more and nothing less.
If the client only wants the usernames, it only asks for the usernames.
The server then uses resolvers. Resolvers are specific functions dedicated to hunting down and returning the exact data fields requested by the schema.
This creates a highly efficient communication bridge between the front end and the back end.
Chapter 7 shifts the focus to databases, specifically explaining why full-stack JavaScript developers often transition from traditional relational databases to non-relational databases like MongoDB. Relational databases store data in strict, unyielding tables with predefined columns.
Non-relational databases like MongoDB store data in flexible, document-based structures.
Because these documents look almost exactly like JavaScript objects, they align perfectly with the mental model used throughout the rest of the application stack.
You never have to translate your data between different formats.
To manage this data effectively, full-stack developers connect their GraphQL APIs to MongoDB using a tool called Mongoose.
Mongoose is an object data modeling tool, or ODM. It provides a structured environment that simplifies database queries and document creation.
While MongoDB is flexible, too much flexibility can lead to messy data.
Instead of writing raw database commands, developers use Mongoose to define strict models for their data.
This ensures that the information entering the MongoDB database adheres to the exact rules set by the application logic.
If we connect this to the bigger picture, writing code is only one part of the professional development cycle.
Chapter 8 covers automated testing with the Jest framework. Writing reliable software requires the professional skill of test-driven development, or TDD.
This practice dictates that a developer should write the automated test for a feature before writing the actual feature code.
This ensures the code meets exact specifications from the start and prevents future modifications from accidentally breaking existing functionality.
Automated unit testing requires isolating specific pieces of code. When testing a module that interacts with external systems like a payment gateway, you do not want to actually charge a credit card every time you run a test.
Developers use test stand-ins to solve this. Test doubles are generic placeholder objects.
Stubs provide predefined answers to specific calls made during the test,
Fakes possess actual working implementations, but take calculated shortcuts.
such as saving data to a temporary memory array instead of connecting to a real slow database,
Mocks are highly specialized objects pre-programmed with expectations.
which form the actual specification of the test itself by asserting that a specific function was called exactly once.
The Jest framework is also used to execute snapshot tests. Utilizing an extension called JustDOM, developers can capture the rendered HTML output of a user interface component.
The framework saves this output as a permanent text file snapshot.
During future test runs, Jest compares the newly rendered component against the saved snapshot.
If the HTML structure changes unexpectedly, the test fails.
This immediately alerts the developer that their recent code changes have visually altered the interface in an unintended way.
Chapters 9 and 10 conclude the core technology stack by covering the critical topics of authorization and containerization.
The OAuth protocol delegates user authentication to trusted third-party services.
Instead of building a complex and secure login system from scratch, a developer can allow users to log in using existing accounts from major technology providers.
This greatly improves security and the user experience. Once a user is authenticated, the server must securely recognize that user during all subsequent requests.
This is achieved using JSON Web Tokens, or JWTs.
A JWT is securely transmitted data structured in 3 distinct parts. The header defines the cryptographic algorithm used to secure the token,
The payload contains the claims.
which are specific pieces of information about the user, such as their identification number and their permission level.
Finally, the signature is mathematically generated using the header, the payload, and a secret key known only to the server.
This signature proves beyond a doubt that the token was genuinely issued by the server and has not been altered by a malicious third party.
Docker containerization is the subject of Chapter 10. Splitting a massive monolithic application into a microservice architecture makes deployment and scaling much easier.
A microservice architecture breaks the application down into small, independent services that communicate over a network.
Think of Docker like a commercial kitchen. It provides everything you need to package and run these services reliably.
The Docker ecosystem provides specific tools to manage these microservices. The Docker daemon is the background service, acting like the kitchen manager overseeing everything on the host machine.
Docker files are text documents acting as the master recipes. They contain all the exact commands needed to build a specific environment.
These recipes are baked into images, which are read-only templates representing a meal prep kit containing the application code and all its dependencies.
Containers are the live, running instances of these images, much like the actual meal cooking on the stove.
Because containers are designed to be temporary and replaceable, developers use volumes to create persistent data storage that survives even if the container is destroyed.
Finally, a tool called Docker Compose allows developers to define and run multi-container applications.
Linking the Next.js frontend, the Express.js backend, and the MongoDB database together with a single coordinated command.
In Part 2 of the book, all these theoretical technologies are actively combined.
The reader is guided through building a sample application called the Food Finder.
This practical real-world exercise integrates TypeScript, React, Next.js, GraphQL, and MongoDB.
Culminating in running automated Jest tests within a live Docker container environment, proving that the entire stack works harmoniously together.
This raises an important question. We have seen how Next.js introduces advanced features like server-side rendering and server components.
As these strict frameworks increasingly blur the established lines between client-side user interfaces and server-side logic, will the traditional definition of a dedicated front-end developer eventually disappear entirely, completely absorbed into the broader domain of server-side engineering?
We strongly recommend that you read the actual book, The Complete Developer, to fully grasp these complex technical implementations and explore the codebase firsthand.
Thank you for listening, friends of the show.
Please subscribe to our broadcast to receive future comprehensive analyses. We wish you a great day.